Do you want to have a look? You're all looking at it, yeah? We said to start with this.
I don't know. Anthony, no? Did you do 40? No.
Okay. So let's have a look at this now.
Are we doing the whole question?
I think we might need parts, yeah, I think it'd probably just be easiest. So if we have a look at 4, it's quite troublesome girls. Right. What? No, I didn't say it was girls' fault. I'm just saying you are troublemaking girls. That's what I'm saying. No, I'm not generalising. Just like you're a troublemaking boy, you know, it's yeah. sorry, a boy with trouble then, okay. What? Okay, let's have a look at this. Now, what this diagram has is 2 squares. So these are squares, so these are all 90, and they're the same square. Now, just to be clear, the reason I know that they're the same square is because I show that they're perpendicular, and also when I do this little dash here, I'm saying they're all the same length. There's also a H here in the middle, and an I here. Also, these have the same angles. These have the same angles here. So if they have the same angle, what angle are they? 60. Okay, so my first question is to find BH. In terms of which ones are they? BA and BC. Right, so here is BA and here is BC. So I can see BH actually, that would be a half BC plus a half BA. Okay, so that's fine. Now, HI. Any ideas what HI might be?
It's the same as BC.
Yep, very good. It's the same as BC. Now, DE. So this is where it gets a bit trickier. I can see that DE firstly is twice BC. Can you see that? Twice B to C, and then plus what? Plus what? Before that maybe? Plus DE. I'm sorry. Oh, sorry, I misread this. DE, I thought it said BE. It says DE. Okay, so DE, so we're just looking at this piece here. Now, what I'll do actually is, I haven't got it drawn in, but I'm imagining that there's a vector here, and there's a vector here that I could add together to make DE. Now I can actually know, if I call this X, I can actually know what XE is. It's a half BA, isn't it? So at least I know that XE is a half BA. The real problem is this DX here. The DX. It's tricky to know.
Yeah.
No!
BH, same as BH.
BH. DE.
No, yeah.
No, DE is not the same as BH. Why not?
Because it doesn't make the square. Oh.
Yeah, it's to do with the angle. What exactly now? No.
The
So,
white.
yeah. Look, guys, you know exactly what this BH angle is here. 45. And what's this DE angle? 30.
Yeah.
So they can't be the same, they're different directions.
Isn't DE same as DE?
Hang on, slow down. You're saying DE, is it? Is the same as...
No, DX is the same as BC.
No, we don't know that either, because that would only be true if this was the same length. But this is not 1 unit long. This is the same length as this. So this has to be smaller. So it's actually smaller than BC. And this is where it comes in with trigonometry. If I go to the side, you know that this piece here is 1 unit long. This piece here is 1 unit long. And this side here is 1 unit long, because they're all the same length. You know that this here is 30, so I want to find the x here. And you actually know what the y is. How big is the y? It's a half. It's a half a unit. So I could say tan 30 equals y over x. So x equals y over tan 30. So that's 1 over 2 tan 30. And what's that, please? So, but with the 2...
We'll just use the Pythagoras root theorem.
Is it root 3 over 2?
Yes. 1 squared minus half squared root 3 over 2.
Oh yeah, I can actually use Pythagoras as well, can't I? You're right. So I can also do square root of 1 minus a quarter, which is root 3 over 2. So you could do it by Pythagoras or by using tan. This number is slightly less than 1. What is it, 0.8 or something?
Hence we keep root 3 over 2.
Oh, we will, but just so we can have a scale. What is it? This number is a decimal. 0.86. So it's slightly shorter. We know it's 0.86 units long. So that means I can know that dx is root 3 over 2, or in other words 0.86, the length of BC. And in fact that's the answer, because we have it done now. DE would be root 3 over 2 BC plus 1 over 2 BA. Yes? Question? No? You want me to go back to this angle note here, is it? Yeah. I just put in the y here. That's substitute, yeah. And then the last one is BE, but I can actually see what the answer is. BE is BC plus CD plus DE.
So 2BC?
Yeah, so 2BC plus the answer I just got. So I won't even write it down. It's the most difficult one there was the DE, which I just did. Can I go back, Hussein, to the main part, yeah? Ali, yes?
Question number 2.
Yeah. Yeah?
AD.
AD.
Oh, sorry, no.
Yeah?
AD or XD? Just a hint of how...
AD?
Yeah. Do you just
Well,
say
AD, yeah, AD would be twice XD. And you have XD from part C.
How do you get XD?
Right, so how to get the XD? So I have a feeling, Ali, that the finding XD is helped because you have the CX previously and the BC previously. I think this is a type of question where each one builds on the last one. So I think if you jump to the middle, you wouldn't be able to do it.
Yeah.
What's wrong? No. Sorry, did you have this taken down? Alright. Right, so we're going to the next topic then. Can I scroll down? Yeah. You don't come to school yesterday. Then when you do come to school, you give me nothing but trouble. Terrible. Okay, so next topic. In the last topic, we were looking at Euclidean vectors. So, for example, here is the vector BC. Now, what we're going to introduce... No, please, are we focused? Yes. Yeah. So what we're going to introduce now to our vectors is the idea of an origin point here, O. So for example, if I asked for OB, that would be there. Or if I asked for OC, that would be there, and OA, that would be there. So I could ask for OA, OB, and OC. These are actually called position vectors, which is the name of the lesson. And basically a position vector is any vector that starts at the origin O. That's all a position vector is. Okay? So it's nothing fancy. Just if it starts with an O, it's called a position vector. But what might seem a bit confusing, so just look carefully, when we have a position vector, we don't have to write the O in. So for example, if I was to write this, A by itself, B by itself, C by itself, you might say, what does that mean? It's A to where, or B to where? The answer is, if there's a letter missing, which there is because there should be two, for example here, the first letter is always O, the origin. So first letter is always O, origin, if there's one missing. So with that I'm going to do a couple of rules. Okay, can I scroll down? So these are position vectors. Yeah. Okay, so for example, our first rule is also, I think, in the title, the triangle law. So for example, we have 3 points here, O, A, and B. And I would like some formula for AB. And you notice that AB here, that's the same as AO plus OB. So AO plus OB. But AO is just minus OA, which we've seen last time. These are position vectors, so it's not necessary for me to write the O. If I leave the O out, it's understood that the O is there. So this is minus A plus B, or in other words, B minus A. So this is a very, very useful little rule, and a very simple rule when we're dealing with position vectors. We can say the vector AB, which is not a position vector because it doesn't start at O, can be written as 2 position vectors, B minus A. So in a way what we're doing is we're changing from a Euclidean vector to a position vector. This is not a position vector, but these two are. And this is a convenient thing to do because then in a later lesson, once we have position vectors, we can start doing things like using I, J, and K for those people who've seen them before. No, but you will see them soon. So we'll have a look at some examples using this triangle law now. So let me do the first one there. Yeah, thank you. No, let me do a more difficult one. We'll have a look at 2, I think. So can I scroll down to do an example?
Yes.
So there are not many new ideas or rules for this lesson. We just have the idea of a position vector which starts at the origin and this triangle law as well. So if we were to have a look at 2, we have the origin O here, point X here, point Y here, point Z here, and then there's a straight line going there, and then another line going here. And this point here is W, and there's a point here M. And I tell you that M is the middle, do I? Yes, M is the middle. And I also tell you that WZ is 5 times xw. So I tell you that this vector here is 5 times this vector here, xw. So you know that this is 5 times of that one there. Okay, so I'll get this book back to you. So what I'm looking for in terms of x and or y is I want vector z, vector w, and vector n. I want these 3 vectors in terms of x and y vector.
Which question is it?
Souvenir?
It's question 2.
You can have it.
So why would I want to remember you?
Why you wouldn't?
Yeah.
What to?
Yes. Memories, yes. Okay, do you have that drawn? Okay, let's have a look here. So the first vector is z. So you have to remember z. What type of vector is z? It's a position vector. So where does it start?
Oh.
Yeah, so it's O to Z. Now you realize, I didn't say this, but I hope you can see it in the picture, that this is a parallelogram. So OZ is exactly the same as what? XY. Now we can use our triangle law here and change this into y minus x, and we're finished. Okay, so that's the first part done. What's wrong?
Y minus x.
That's it. Because I said write in terms of x and y.
Yeah.
Well, leave him alone, okay? Well, just leave him alone, okay? This teacher's picking on him, alright? He doesn't need you as well. Yes?
Can I write that on 0y, oy minus os? Y.
No, leave the O out.
But,
You are asking me, can you write the O in?
yes.
I'm saying leave it out. Come on.
You leave it in the example now, so keep your understanding.
I suppose I'd accept that. Yes, it's fine. It's fine, Tanish, it's fine.
With broken tennis.
Yeah. Just don't care anymore. Alright, and W next. So, W is OW. Okay. Now this one gets a little bit trickier because we really have to think about what way we can go with OW.
Oh, there's
Yeah, we can go with OX plus XW. That'd be one way to go about it. I don't think there's any one way which is really, really quick. So we'll just go with OX plus XW. But then you need to remember, I think I told you that the WZ is 5 times bigger than the XW, is that right? OX is X, and then XW would be how much of WZ? Well, it'd be a fifth, yeah, of WZ. But, wait, don't write that last bit down. Well, you can write it down, but I'm just going to say that we're trying to not have the W here. So rather than writing WZ, 1/5 WZ, how could I write this as an XZ? So what I'm looking to do is, instead of, where's it gone, WZ here,
XW.
605
I think we have it there, yeah. Remember, WZ would be 5/6 of what? XZ. So another way of writing it, which I think is more useful for us, is X plus 1/6 XZ. Can you see that there? That's a Z there. Now, what rule should we use next? What do you think we should do next? I think we should split the xz into z minus x. We want x in our answer. What do we not want in our answer here? The z. But remember, we have a formula for z from part 1. It's right here. Z is y minus x. So I can sub that in. I get x plus 1/6 y minus x minus x. So I get x plus 1/6 y minus 2x. So in total I have x minus 2/6 x, which is 2/3 x, and then plus 1/6 of y. Are there? Oh, I just left out a minus. No, it's not. Sorry.
Minus 2x plus x.
It's minus.
No, it's minus 2/6 of x. Yes.
So what happened after the bracket of
Here to here? I used my answer from part 1. I know that z is y minus x. So I subbed it in here. Replaced the z with y minus x. Substitution. So you're starting to see now they're getting a bit longer, a bit more difficult to do. You have to think about it carefully. The last part here is the m vector. So I just go back up to the diagram for a moment. I think for m,
W plus WM.
yeah, OW plus WM.
OX, X, Y,
Yeah, you can go OX, XY, Y. You know what? Why don't you try it first, and then I'll do it. So try and get the vector for m for me. I will in a second. Relax. So I want the OM vector. Have you forgotten integration? This isn't bad.
oh yeah, that's it.
Integration of improper partial fractions. Have you forgotten it so quickly?
Very,
Yes.
very long.
Very long, yes.
Very good.
And
You know complicated, you are.
yeah, but so is this. So this requires too much thinking, isn't it? Yeah, this is the main problem.
Memorization.
Yeah.
The thinking part.
This is your weakness in the exam, isn't it? Okay, do you have this one done? From looking at it now, actually, I don't think it's as long as the last part, actually. So let's have a look at it. I'll just write it on the top here. So, M equals OM, which equals OW plus WM, which equals W plus W plus WM, which equals W plus a half WY, because WM is a half of WY. this equals, on the next line here, W plus a half Y minus W. So this is a half W, plus a half Y. But you have a formula for W from the last question. What was the formula for W? 2 over 3x plus 1 over 6y plus a half y. So if I just add these together, let me see, I have 1/3 x, and then I have 1/12 y plus 6/12 y, so 7/12 of a y. So this is the answer here.
What about the first W?
Huh?
The W at the start?
Here?
Yeah.
What do you mean?
What happened to that? This one, yes?
Oh, this W, and then I expanded and added this W to this W, and it became a half W, yeah. Now, you get these types of questions in the exam from time to time. They give you, now it's not very often, but sometimes they give you a diagram like this, and they would ask you for things like what I just did, Z, W, and then M. And I really don't think this is a bad question compared to what you have to do in integration, what you have to do in trigonometry. Don't forget about all those stuff you did at the start of the year with inverse, injective, bijective, surjective, or we used the other words, didn't we? One-to-one, one-to-many, many-to-one, all this stuff there. Yeah.
I still don't get that one.
Yeah. So what I'm saying is, like Angela Joshua, what I'm saying here is this chapter of vectors, I feel, is an easier chapter than what we've been doing. Don't forget the last chapter I didn't think was too difficult, with Newton-Raphson and the fixed points. I don't think they were too difficult. That actually would be a good name for a band. Newton-Raphson and the fixed points. Okay.
When they take electronics.
Yeah, something like this I'm picturing. Yeah. Yeah. No, and there's anyone here sings? Sorry, anyone here sings well? Great. I don't know if she can do electronic effects. Yeah, that's what I'm going for here, yeah. Okay, so I did number 2 there. There's only 5 questions in total. So, no, that comes wrong. We should be able to get a few of them finished before we go. So try some of them now. Is it likely that you're going to take on the board or back here? Yeah, sorry. Don, Harry, the same. Yusuf, Ali, get working, please. Yes, sir. Yeah, that's what so far it's the same.
Wait, number 3 is
Yes, that's it. Yes, go on. I think The answer is back to wrong for number 2 for sure. That's A and B. I think it's wrong. Yeah, I know. So I just put the wrong page there, okay? So just try the question and I'll give you the new page next time with the answers on.
The same message has the right page.
When's the last time you typed it? So I'm averaging 1 per semester, right? Like I said, I think the wrong page is at the back for the answers, okay? So I'll give you the answers next time. But just try the questions anyway. Just check your answer with someone who's smarter than you.
This is